Hey guys, in this video we are going to see how to convert a complex number from rectangular form to polar form. And in rectangular form the complex number look like this, a plus jb, and if we convert this one into polar form, that's going to look something like this, r and the angle theta. Okay, now let's look at an example. Let's say we have a voltage and we express this one as r angle theta, and we can write this one, this is similar to r e power j theta. We can express in these two way, and to convert this one into rectangular form we use Euler's identity. If you remember, the Euler's identity will convert this one like v is equal to r cos theta, and the imaginary part is going to be j sin theta. Okay, and also we can multiply this one and express this one as r cos theta plus r o j r sin theta. Okay, so these are the ways we can express this one. Now let's analyze this one graphically. Let's see how it's going to look like in a graph. Okay, here we have a graph, and this graph is going to have real part and the imaginary part, and the x-axis is the real part and the y-axis is going to be the imaginary part. Okay, and in our case a is the real part, so we are going to have a right here, somewhere here, and b is the imaginary part, so we are going to have the b somewhere here, and the angle that's making with the horizontal, that's going to be the angle theta. Okay, and this is r, and that's it. So this is how it's going to look like. And let's look at the conversions. Polar conversion and rectangular form. Rectangular form. Okay, polar conversion, to find the distance, like when we express this one in a rectangular form, we express this one as a plus jb. We'll just point the location like right here, but in polar conversion we express the distance, like distance and the direction, because you can have this distance r from here to here that is measured, but this can be anywhere. Like you can put this line anywhere in this graph, but that's not correct, right? We have to express where it's exactly. That's why we have to express the angle also. That's why we put theta. So first we calculate the distance using Pythagorean theorem, because we know this location a and also we know the b, so we can calculate the distance from the origin to here using Pythagorean theorem. That's r. So polar conversion we use r square is equal to a square plus b square, and therefore r is going to be equal to square root of a square plus b square. And also we can find the angle using, okay, let's look at the angles first. A is going to be equal to r cos theta, because you can see in the x-axis we are going to have cos theta, right? A is going to be equal to r cos theta, and b is going to be equal to r sin theta. Okay, so these are the things we have to know. A is equal to r cos theta, b is equal to r sin theta. Using this one we can find this theta angle. So theta is going to be equal to tan inverse b over a. So these are the things we have to know. Now let's look at an example. Let's look at an example numerically. Let's say we have 2 plus j8, and if we draw the graph for this one, in the graph we are going to have the real part and the imaginary part, and let's say this is our real part. X-axis is the real part, y-axis is the imaginary part, and this is, in the real part we have 2 away, right? Let's continue here. So this is 1, this is 2, so this is 2, and in the imaginary part we have 8. So let's say this is 1 2 3 4 5 6 7 8, somewhere here. Okay, let's say this is 8, and this is going to be the location. Okay, so this is in rectangular form. Now to convert this one into polar form, we have to look at the distance from the origin. So this distance we have to find, that's going to be the r distance. Okay, r distance, and we have to also know the angle, because distance is not enough, because this distance can be anywhere in the graph. So we have to know exactly where in the graph this r is going to be. So that's why we had to find this angle theta. Now to find the distance, as we seen before, we use this Pythagorean theorem. Since we know the opposite side and the adjacent side, we can find the r value. So r value is going to be opposite square over opposite square plus adjacent square. Okay, like you know Pythagorean theorem, right? This is going to be 8 square plus 2 square and square root, and that's going to give us 64 plus 4, 68. Square root of 68, you will get 8.2, right? So this is going to be the distance. Now to find the angle, we can use tan inverse b over a. Theta is going to be equal to tan inverse b over a. In our case, b is, if you look at the graph, b is the opposite side over a, because tan is opposite over adjacent. In this case, opposite is 8 divided by 2, and if you calculate this one, you will get the angle that's going to be 75.9 degree. So finally we can express our final answer as 8.2. Okay, let's get rid of this. Okay, 8.2, and the angle is going to be 76, almost approximately 76 degree. And that's how we convert a rectangular complex number to polar form of complex number. I hope this helps. Thanks for watching.